Hey everyone, let's do some 7.3. There is more hypothesis testing coming up, so just different types. This one is when you do not know the population standard deviation. We're going to use the t-distribution for these, okay? But they're still about a mean, so they're still about the mu. So it's really close to 7.2. In 7.2, you use z, and in 7.3, you use t. And when you're deciding which one to use, the only thing it's based on is the standard deviation. I mean, there's always a standard deviation given, or you can find it with the raw data, but is it a population standard deviation? Then that's when you use z. If you only have a sample standard deviation, then that's when you use t, and that's it. So this section's all about the t. There are two methods, just like before. We have rejection region method, which we'll do first because you can use the table for that method. And then the p-value method, you have to use StatCrunch. So we'll do that last. So probably the preferred method in this section will be rejection region, okay? Otherwise, the steps that you take are the same, mostly the same. The main difference is the formula, a little different. You have a t instead of a z, and you have s instead of sigma. Otherwise, the structure is the same. And then when you find critical values, you're going to have to use the table, or you can use StatCrunch. But then 5 and 6 are the same. So we'll first practice finding critical values. There are 3 possibilities, left, right, or two-tail, and there's the directions for each one. And we have 3 examples to do. So let's try the left-tailed test. First, you have to figure out, df, and that's n minus 1. So I'm going to do 20 minus 1, 19. Okay. And then I have alpha 0.05. So now I'm going to go to the table, look those things up, and figure out what that critical value t sub 0 equals. Okay. One thing to note, if it's a left-tailed test, you're always going to put a negative on the value. So I already know I'm going to put a negative there. There's no negatives in the table, so you just have to remember to put it on there. Okay, so let me on my computer show you the table. So again, I'm looking at DF19. And I've got to go to my table 5. And that says T distribution. Going down to DF19, there it is. And then it says do one tail alpha. 0.05, that's the second column down to 19. So I see a 1.729. So my answer is negative 1.729. Okay, let's look at the next one. If it's a right-tailed test and n is 10, so the first thing I'm going to do is 10 minus 1 to get the 9. That's the df. So I go down to 9 right there. And then alpha 0.01, still one tail. So one tail 0.01, it's that fourth column over. 2.821. That would be my critical value. If it's a right-tailed test, it's just whatever you see in the table. You don't have to do anything fancy. Finally, the two-tailed test with n equal 15. So I'm going to do 15 minus 1, 14. So I'm right here at 14. And for two-tail, it says use two-tail alpha and then put a plus minus on it. So two-tail alpha 0.1, second column, down to 14, 1.761. So my critical value will be plus or minus 1.761. And those are the 3 cases that you'll run into with critical values. So let's go back to the handout. And I can show you what I was just writing down. Just make sure we have those answers written. So we've got those 3 final answers. Okay, so you can refer to that when you're looking for critical values. Let's see how it applies to running a full hypothesis test. This one, One thing to note on this one, we do have to do something here. I have to add something. Assume the population is normally distributed. That should be in this problem. Otherwise, you actually can't do it. The reason is because n is only 20, it's less than 30. So anytime n is less than 30, to qualify for a hypothesis test, you have to have that the population is normally distributed. So I'm going to sneak that in there. Let's just pretend it's there. Okay, step 1, HOHA. Here we go. This part you know how to do. The claim is mu less than 13. That's an HA because it does not have equals. HO is greater than or equal to. Flip it around and reverse it. So this is going to be a left-tailed test because of the HA, right? HA defines what type of test. HA is less than, left tail. Step 2 is verify. Okay, that's why we had to squeeze in that little statement about the population normally distributed. So we're good there. So we're going to go right to our test statistic. T now, not Z, right? It's T. X bar minus mu, 12.6 minus 13 over S, 1.2 divided by square root of 20. So following along with that formula listed above under step 3. Get out your trusty calculator. Make sure to put those parentheses around the numerator and denominator to make sure the order of operations get calculated correctly. And this should be negative 1.49. And that's step 3. Step 4, find the critical value. So go to your table. We have DF is 20 minus 1, 19. So I'm going now to my table, looking up 19 along with 1 tail 0.05, which is that second column. And I'm seeing a 1.729. So it's negative 1.729 because this is a left-tailed test. Throw the negative on there. Now remember how rejection region works. We draw it, and that negative 1.729 defines that shaded region. And then you're going to ask yourself, is this test statistic over here in the shaded region or not? So let's plot it. Negative 1.49 would be to the right of this number, right? Just thinking regular number line. So the test statistic is not in the rejection region. If that's the case, you always fail to reject H sub 0. Okay. Next, we're going to put it all together for a conclusion. So what did we do? We failed to reject H sub 0, and the claim is H sub A. Anytime those two are linked together like that, the final sentence is, there is insufficient or not enough evidence to support the claim. And those are the same conclusions we did in 7.2. That conclusion table works for these as well. Okay. Okay. Now we've completed our 6 steps. I think we just ran through those 6. The real difference again is steps 3 and 4 look a little different. Otherwise, it's the same as 7.2 for the rejection region method. Okay, so we can try another one. Let's get a HO and an HA. This one, the first sentence is that average cost is 22,500. That's a mu. So mu equals 22,500. And the opposite of that is not equal to. So this is a two-tailed test. Okay. You claim the information is incorrect. So you claim that it's not equal to. pen thing just broke. All right, let's see if this still works. Okay, we can verify. We have that the population is normally distributed. Sorry, had a pen break, so a little editing. I'm back, got a new pen. Population is normally distributed. Step 2 is verified. So step 3, we've got to do a t-score. So I'm going to find my x bar. There it is, the mean of the sample. 21,545. Population mean is what's given in the hypotheses. Let's see, we need an S, sample standard deviation. Notice that is a sample standard deviation because it's based off of the sample of 25. And that is the n, so I need square root of 25 right there. Okay, so there's my t. So I'm gonna practice calculating that real quick. See what you get. This is looking like about negative 1.58. Okay, next we need a critical value. And since this is two-tail, I already know it's going to be plus or minus. And so I'm going to, using n equal 25, so df is 24, and a two-tail 0.05. So practice looking at that. Look at two-tail 0.05, that's that middle column, and go down to 24, and you'll see a 2.064. So it's plus or minus 2.064. Drawing that out, it's a two-tailed test. We have negative 2.604, positive 2.604. And then now plot your t-score in there, negative 1.58, somewhere around there. It's just not in the shaded region. Okay, so if it's not in the shaded region, you always are going to write or choose fail to reject H sub 0. Okay, so this one seems similar to the last one. HA is the claim, fail to reject H sub 0. There is insufficient evidence to support this claim. So I would just write that out. It's for your claim, right? To support your claim. You thought the information was correct. There's just not evidence to back you up here. Okay. So that gets us through page 8. It's a good point to stop. I'll continue on the next video with the rest. Okay. See you later.